Now we're going to talk about something that's a little bit different, section 11.5, that's about geometric probability in areas of sectors. So let's talk a little bit about what probability is. Probability is, what are the odds that at random you would pick or you would hit, if I was throwing something or I would pick something, that an event would happen. Okay? That's what probability is. What's the probability that a certain team will win? What's the probability that if I throw a dart at the dartboard, I will hit this point? What's the probability if I throw this, it's going to knock over this milk bottle or whatever else? So we're looking at probability. What we have to do is we have to look at what is the opportunity for me to hit it, how much space does it take up, and what's the total space I'm looking at. We're looking at geometric probability. We're looking at areas or volumes or whatever. This point we're looking at areas. What's the total area that I can pick from? And what is the area of what I am supposed to hit or what I would like to pick from? So what we've got to do is we've got to be able to calculate the area of those and then compare them, put them together in a ratio like we learned in chapter 7, and compare them proportionally and determine what that probability is. Okay? So what we're going to do is we're going to do some samples. The best way to do this is do samples. And not really any discussion or lecture here. It's just we're going to do a bunch of samples and show you how to do this. Got a picture on the board of circle C. Given circle C, we would like very much to find the probability of picking a random point inside circle C that is in the shaded area. And we have this shaded area here. Now we have defined that shaded area as, you'll notice that it takes up 60 degrees of the entire circle. Now how many degrees are in the entire circle if we go all the way around? Yeah, 360. So we're taking up 60 degrees of that 360 degrees. We're also given the radius of 5. So what we can do is we can figure out what the area of that circle is and then figure out what the area of that particular space is. So let's do that. What we've got is area of a circle equals pi r squared. In this case, r equals 5, so we're looking at the area of circle C equals pi 5 squared equals pi times 25 equals, let's get our handy dandy little calculator, 25 pi times equals 78.54. All right? So the entire circle equals 78.54. Now, what we've got to do is figure out what part of that circle is a shaded area. Well, what did we say? Shaded area is 60 degrees. The total circle is 360. That equals what? We can take that off. That equals basically 1/6. All right? So basically, what I'm looking at is I have a 1/6 opportunity of getting that. Alright, so I can divide this by 6. Area of the sector. This is known as a sector. This is a sector of that circle. It's a 60-degree sector of that circle. So let's identify this. This is a sector. So we're going to look at that sector. So the sector, area of the sector equals 78.54 divided by 6. Get in any little calculator. We're looking at basically 13.1. Okay? Now, what's the opportunity that I'm going to pick the random out of this? Well, the area of that sector is basically what I have to do is I have to look at area of the sector divided by area of the circle equals circle C equals 13.1 divided by 78.54 equals. 13.1, 13.1, 13.1 divided by 78.54, and that equals 16.668, or equals 16.68%. Well, let's get this right here. Equals 0.1668, or that equals 16.68%. Okay? Now, guess what? This right here equals what? .1667. Over here we rounded a little bit, so we got a little off, which equals 16.67%. Two ways to do it. Okay, we can take the area of what we'd like to hit, or what we'd like to pull our point out of, and divide that area, or the area of that sector, by the total area of the figure and get it. Or, in this case, in the circle, we can sit there and say, wow, the 60 degrees is taking up 1/6 of the circle. How do I know that? Because at 60 degrees, what's the entire circle of 36? So it doesn't matter what the radius is. It doesn't matter what the area is. I know that this is going to take up 1/6. 60 over 36, 1/6 of that circle, and so I can find it that way. All right, we're going to do several other examples and help you out with this. And so let's get started on them.